We're going to go ahead and review a few things when we're talking about graphing quadratic functions. Now, a quadratic function has an x squared in it, and it's going to have some number other than 0 in front of it, because if it was 0, it would knock out the x squared and it wouldn't be quadratic. Now, it may have an x to the first being added or subtracted, and it may have a normal number, a constant, being added or subtracted. Doesn't have to. We also have the axis of symmetry. The axis of symmetry is a vertical line that cuts your parabola in half so that each side of that vertical line are mirror images of each other. That axis of symmetry goes through the x-coordinate of the vertex. So when we're looking at the axis of symmetry for this problem down here, we're going to go ahead and do the negative b over 2a. A is the number that's in front of your squared term. B is the number in front of x to the first power. C is the number that's added or subtracted without any variables. So when we do the negative b over 3a, we're going to do the opposite of 3. So we get this over 2 times 1. So the x-coordinate of our vertex is negative 3.5. We want to choose 3 numbers on each side of negative 1.5. If this is a nice, neat number, no decimals or fractions, I would definitely include it here. Now, could you include it here of negative 1.5 and still choose 3 numbers on each side? Yes. Then all we're going to do is just make ourselves a table. Choose 3 numbers on each side of negative 1.5. Take 1, plug it in. Take 0, plug it in. Take negative 1, plug it in for x right here. Take negative 2. Remember, a negative 2 times a negative 2 would be 4 minus 6 minus 1, and so on. Now, all we have to do at this point is plot these points. Over 1, up 3, over 0, down 1, left 1, down 3, left 2, down 3, left 3, down 1, left 4, up 3. And when we plot those points, we get this blue graph. We could also include our axis of symmetry. We won't have to, but we could put it in there, and you can see the part that's to the right of that axis of symmetry is the mirror image of what's on the left. So if I would take the part that's on the right and flip it over my axis of symmetry, I would get the part that's on the left. You can use that idea to help you make sure you're graphing it correctly when you were plotting your points. If you don't get the axis of symmetry to look like it's each side is the mirror image, you either messed up in finding your axis of symmetry, or you made a mistake plugging stuff into your function and figuring out your y values of your table. So let's go ahead and graph this. Sometimes it's nice to have the y-intercept. That's where you're crossing the y-axis, and on the y-axis right here, you're not left and right, so that means x is 0. Well, if x is 0, we just get plain old normal 2. Then we're going to go ahead and find the equation for our axis of symmetry. That's that x equals negative b over 2a. And in this case, a is what's in front of your, well, a is always what's in front of your squared term, which is 1, and b is the number that's in front of x to the first power, which is negative 4. So we'll take the opposite of negative 4 over 2 times 1. And so we get 4 on top over 2 on the bottom, so we get our axis of symmetry being x equals 2. I've seen a lot of people put their axis of symmetry of just being 2. But keep in mind, if we don't have the x equals here, it's just a number. A number is not going to be a line on our graph. We have a vertical line. Remember, a vertical line has all the x-coordinates being the same. So an axis of symmetry has to be x equals whatever that number is. Now, the x-coordinate of your vertex is just 2. So we'll go ahead and put down 2, and we'll choose 3 numbers on each side. This is our t-chart. All we have to do now is go ahead and plot those in to our function, and we'll go ahead and graph that. So I'm going to go ahead and try to do it the slightly easier way than plugging them in all by hand. I'm going to go ahead and take my graphing calculator and go to my y equals, and I'm going to type in my function. 2 minus 4x plus x squared. So double check to make sure you typed it in correctly. Now I'm going to go back and look at my table again. My table starts at -1. So I'm going to start off by looking at table set, which is second window. I need to make sure that these are both on auto. If they are, don't worry about changing it. You shouldn't need to change it. My delta table here is how much I'm going up by. And you'll notice over here I'm increasing by 1. So I'm going to leave that as 1. But I want my table to start at -1. So I'm going to put this as -1. And then hit enter. Now I need to look at my table. So table is second window. So I'll go second graph. I'll get my table. And then you'll notice here I have my table. I can quickly copy that down. I can then just plot those points. And I get my graph. Your vertex is this point right here, which is over 2, down 2. So your vertex is 2, comma, -2 in parentheses. Now, if your parabola is opening up, then you're going to have a bottom point, so you're going to have a minimum. And it opens up when your number in front of your squared term is greater than 0. If the number in front of your squared term is less than 0, you open down and you have a maximum. So the x-coordinate of your vertex tells you when the max or min occurs, but the actual max or min is the y-coordinate of the vertex. So let's go ahead and look at this function here. We know this function has a maximum since a is negative. And remember, if a is negative, that means our parabola is opening down and it has a top point. It says find when our maximum occurs and then find what is our maximum. When is the x-coordinate of your vertex, which remember is -b over 2a. So we plug in -b over 2a from our function and we get 1. So when does our maximum occur? When x is 1. What is the maximum? All we have to do is just take this and plug it into our function because it's the y-coordinate of the vertex. So we take 1 and plug it in, and we simplify down. Now, make sure you note that this negative is in front, so you have to do your squaring first and then take the opposite of that.